Q6518. During a steady climb, the rate of climb depends on A. Excess power, B. Excess thrust, C. Thrust available. The correct answer is A. During a steady climb, the rate of climb of an aircraft depends on the excess power available. Excess power is the power that remains available after overcoming the power required to maintain level flight at a given airspeed. It represents the additional power that can be utilized to climb. To understand this, let's break down the components involved. Power. Power is the rate at which work is done or energy is transferred. In aviation, power is typically measured in horsepower, HP, or watts, W. It is the product of thrust, or force, and velocity, speed. Power is required to overcome the drag and maintain forward motion. Thrust. Thrust is the force produced by the aircraft's engines or propulsion system that propels the aircraft forward. It is the force that counteracts drag and enables the aircraft to maintain or change its speed. Excess power. Excess power is the power available beyond what is required to maintain level flight at a given airspeed. In other words, it is the power that can be utilized for climbing or accelerating. During a steady climb, the aircraft needs to overcome not only the drag, but also the force of gravity to maintain an upward trajectory. To climb, the aircraft must generate enough excess power to overcome these forces. 6519. During a steady climb, the angle of climb depends on A. Excess thrust, B. Power available, C. Thrust required. The correct answer is A. During a steady climb, the aircraft is ascending while maintaining a constant speed. To sustain this climb, the aircraft needs to overcome the opposing forces of gravity and drag. The thrust generated by the engines plays a crucial role in enabling the aircraft to overcome these forces and maintain a climb. Excess thrust is the amount of thrust available beyond what is required to maintain level flight. In a climb, this excess thrust is utilized to overcome the additional forces acting on the aircraft, namely the increased gravitational force and the increased drag due to the inclined flight path. By having excess thrust, the aircraft can generate more lift than is needed to balance its weight, allowing it to climb. The angle of climb is essentially the angle between the aircraft's flight path and the horizontal reference plane. Increasing the excess thrust increases the vertical component of the aircraft's velocity, thereby increasing the angle of climb. Power available, on the other hand, refers to the total power output of the aircraft's engines. While power is related to thrust, it is not the sole determinant of the angle of climb. The efficiency with which the available power is converted into thrust depends on various factors, including the aircraft's configuration, weight, and drag. Therefore, power available alone does not dictate the angle of climb. Similarly, thrust required is the amount of thrust needed to counteract drag and maintain level flight. While thrust required is a critical parameter for determining the aircraft's performance in level flight, it does not directly determine the angle of climb. It represents the minimum amount of thrust required to counterbalance the drag and sustain level flight. However, during a climb, the aircraft needs to generate more thrust than the thrust required to overcome the increased drag and gravitational forces. In summary, during a steady climb, the angle of climb depends on the excess thrust. Excess thrust allows the aircraft to generate the necessary lift to overcome gravity and drag, enabling it to maintain an ascending flight path. Power available and thrust required are important factors in aircraft performance, but are not directly responsible for determining the angle of climb in this context. 6529. Which statement is true regarding the forces acting on an airplane in a steady-state climb? A. The sum of all forward forces is greater than the sum of all rearward forces. B. The sum of all upward forces is greater than the sum of all downward forces. C. The sum of all upward forces is equal to the sum of all downward forces. The correct answer is C. In a steady-state climb, an airplane is ascending while maintaining a constant speed. Several forces come into play during this phase of flight. Let's discuss them in terms of vertical forces. Weight. Downward force. Weight is the force acting vertically downward due to the gravitational pull on the aircraft. It is the product of the mass of the airplane and the acceleration due to gravity. Weight acts as the primary downward force throughout the flight. Lift. Upward force. Lift is the force generated by the wings of the airplane as a result of the airflow over the wing surfaces. Lift opposes the weight of the aircraft and allows it to maintain an upward trajectory. In a steady-state climb, lift is the primary upward force. Thrust. Horizontal force. Thrust is the force generated by the aircraft's engines that propels it forward. In a steady-state climb, the thrust is primarily used to overcome drag, which is the resistance encountered by the aircraft due to its motion through the air. While thrust plays a role in the overall performance of the aircraft, it does not directly affect the balance of vertical forces. Drag. Opposing force. Drag is the resistance encountered by the aircraft as it moves through the air. It acts in the opposite direction of the aircraft's motion. In a steady-state climb, drag acts rearward, opposing the thrust of the engines. However, since the question specifically asks about vertical forces, we can disregard the effects of drag for the purpose of this analysis. When considering only the vertical forces, weight, and lift, we find that the weight of the aircraft is balanced by the lift generated by the wings. In a steady-state climb, the aircraft must generate enough lift to counteract its weight, resulting in an upward force equal to the downward force. This is represented by statement C, where the sum of all upward forces is equal to the sum of all downward forces. 6528. Which statement describes the relationship of the forces acting on an aircraft in a constant power and constant airspeed descent? A. Thrust is equal to drag. Lift is equal to weight. B. Thrust is equal to drag. Weight is greater than lift. C. Thrust is greater than drag. Weight is greater than lift. The correct answer is A. In a constant power and constant airspeed descent, the aircraft is descending while maintaining a constant power setting and airspeed. Several forces are at play during this phase of flight. Let's analyze them. Thrust. Thrust is the force generated by the aircraft's engines that propels it forward. In a constant power descent, the thrust is maintained at a consistent level. However, in a descent, the direction of thrust is opposing the aircraft's motion and acts in the opposite direction to the flight path. Drag. Drag is the resistance encountered by the aircraft as it moves through the air. In a constant airspeed descent, the drag remains constant, as the airspeed is maintained at a consistent level. Drag acts in the same direction as the aircraft's motion during descent. Lift. Lift is the force generated by the wings of the aircraft as a result of the airflow over the wing surfaces. In a descent, the lift force decreases compared to level flight. This is because the wings are producing less lift to counteract the reduced weight of the aircraft. In a constant power and constant airspeed descent, lift is equal to the weight of the aircraft. Weight. Weight is the force acting vertically downward due to the gravitational pull on the aircraft. It remains constant during the descent, just as it does during level flight. Now, let's analyze the relationship between these forces. Since the aircraft is descending at a constant airspeed, the thrust must equal the drag to maintain this speed. In other words, the forward force generated by the engines must be balanced by the opposing force of drag. Additionally, since the aircraft is descending in a controlled manner, it means that lift is equal to the weight of the aircraft. This ensures that the downward force of weight is balanced by the upward force of lift. 6508. Adverse yaw during a turn entry is caused by A. Increased induced drag on the lowered wing and decreased induced drag on the raised wing. B. Decreased induced drag on the lowered wing and increased induced drag on the raised wing. C. Increased parasite drags on the raised wing and decreased parasite drag on the lowered wing. The correct answer is B. During an aircraft's turn, the ailerons are used to roll the wings and initiate the desired bank angle. Adverse yaw refers to the tendency of the aircraft to yaw in the opposite direction of the intended turn. This yawing motion is caused by differences in drag between the two wings. When the ailerons are deflected to roll the aircraft, the wing on the inside of the turn, lowered wing, generates more lift than the wing on the outside of the turn, raised wing. This difference in lift production creates a difference in induced drag between the wings. Induced drag is a type of drag that is generated as a byproduct of lift production. It is proportional to the lift generated by the wing. In a turn, the lowered wing generates more lift, and therefore, it also produces more induced drag. Conversely, the raised wing generates less lift and, consequently, less induced drag. The difference in induced drag between the wings creates a yawing moment. The wing with higher induced drag experiences more drag-induced yawing force, which tends to yaw the aircraft in the opposite direction of the turn. This is the adverse yaw. To counteract adverse yaw, aircraft designs and control techniques are employed. One common approach is the use of aileron differential or aileron rudder interconnect systems, where coordinated application of rudder input with aileron deflection helps mitigate adverse yaw by minimizing the drag differential between the wings.